Well, a very good morning, everybody, and welcome to the second event of the 2021 GATCO-BALPA Symposium. My name is Mike Thrower, and I'll be the host today for the event entitled Automation and Artificial Intelligence in Aviation. The first event last week covered lessons of the pandemic and navigating the future, and is now available for viewing online if you want to catch up with the excellent panel that we put together for that occasion. Like a lot of flights over the years, this particular event has been slightly disrupted due to some unforeseen circumstances, and we've had to jiggle the presentation around. And I have to thank Stuart Clark for stepping in as a presenter instead of host. Crewing have then called me out of standby to be host instead, but we'll all be doing our best to arrive at the destination on time. I retired last year after 44 years with British Caledonian and British Airways. My last 25 years was as a type rating instructor and examiner on the Boeing 777 and Boeing 787. My role here today is as chairman of the BALPA Air Traffic Services Study Group, which is the group that liaises with GATCO on air traffic matters. So I'll be coordinating the two presentations that we have today and asking the questions that you wish to ask. We try to keep these events as informal as possible, and I'd encourage you to get involved and ask those questions that you've always wanted to ask. If I could ask you to put those questions in the Q&A function of the WebEx software at the top there, please put them in at any time as you think of them. I have Phil Tanner in the background. He's collating the questions, and we'll put these to the presenters after they've done their presentation. We'll use the chat function for any general discussion of technical messages, etc., if you just want to chat amongst yourselves. In addition, could I just make sure you're all muted with your video off to protect the bandwidth for this recording. We will be recording the event for future viewing and distribution. So today's event is looking at current and future technologies that are available to assist the pilots and controllers in their roles and to increase awareness of both groups of the systems that are in use at the time. Stuart, I've already mentioned, he'll discuss the latest technology in use on the A380 and the A350. But presenting first and then answering questions are Peter Hendricks and Adam Tyser from Eurocontrol. So if I can hand over to Adam and Peter for the first presentation, please.
Hi, sorry, Mike. Sorry, we were trying to find the unmute button. We thought it would go automatic.
Don't worry, it's a problem of COVID. Thank you. Over to you.
So good morning, everybody. Good morning from Maastricht Upper Area Control Center, Eurocontrol. We'll be talking to you, and thanks for the opportunity to be able to show what our plans are. We'll be talking to you about automation. And also because it's a big hype now, and we are also using it about artificial intelligence, to what extent that we are currently using this in Maastricht and maybe use it in the future. My name is Peter Hendricks. I'm an engineer as background, but I spent most of my life in operations in the military, and then later on in Maastricht. Spending my time there in order to translate the user requirements, the operational requirements, into the technical requirements for implementation. So making the translation between ops and technical worlds, which are two completely different worlds. Currently, I'm the head of ATM development in Maastricht, and I'm joined here by Adam, who will introduce himself, please.
Yeah. So I'm Adam Tissa, and I work in Peter's unit, basically in the requirements team, where we prepare all the user requirements and process them and translate them for the engineers. My background is applied cognitive psychology, so it's more like the usability, user experience, human factors side of system development. And today I'm going to be giving the first part of the presentation, which is more about the strategic view, or our strategic view on automation. First of all, can you see our slides? Are you sharing it? Because we have shared them, but
we can see the first slide by the look of it, Adam. We can't actually see you. We can only see Peter at the moment.
okay. No, anyways, yeah, I'm separate.
Okay, here we go.
That's brilliant. Yeah, all in full view.
So the first part is more about the strategic view on automation. Basically, what we did is that we started to tackle this whole automation topic with a study. I mean, of course, we've been automating for decades when we think about system features. So there are certain system functionalities that have already been advanced, and they have achieved a very high level of automation, like SSR code change, like the automatic updates of trajectories. So there are certain features in the system that have been there for a long time, and they were automated long ago. Or conflict detection, when we think about short-term conflict detection. But okay, we wanted to look into, okay, in the future, most probably, we are only going to be introducing further pieces of automation. So what shall we do? How shall we do it? And do we need some kind of more systematic approach, or this kind of user need approaches already defined that we have? So to put everything in a context, we reached out to the academic articles and CESAR documents and reports. And that's where we also come across this level of automation taxonomy. So this is basically what we started to use. This is a simple, or let's say simple, yeah, taxonomy on how automation can be applied and how it affects the workflow of the human. So here you can see that from the top to the bottom, the level of automation changes. So more you go downwards, the higher level of automation you achieve. But what was new from this CESAR report, with the help of Deep Blue, with the input of Deep Blue, is that they also split the different levels of automation based on what kind of cognitive stages the workflow goes through when a controller or a pilot or any user is working. So basically, they split the workflow into 4 cognitive stages: perception, so when you really like gather information; analysis, so when you process information and you try to make sense of it; and decision, so when you actually look for options like what could be done and what should be the action to be taken; and then the execution, when you're actually taking the action. Now, when it comes to automation, it's quite similar. So we can also look at automation like, okay, where it appears, on which column it appears, and at what level it is already. So the first task, let's say, we created for ourselves in this automation study is just to map what we have already and how far we are with automation. Also because, yeah, this taxonomy also, let's say, teaches us that automation is not only something that affects decision making. So sometimes, especially when you ask ATCOs like, okay, what do you think, how automated is your job actually? Then they would say, okay, not really, because yeah, all decisions are made by me still, but okay, we have some nice features. So most of the time they are not aware of those automated features that are already there, but they don't really affect their the decision that they make. They only prepare the information for those decisions. So they only appear on the other columns. Now, and then basically we did a thorough analysis, what kind of tasks there are, ATCO tasks, what are performed by both the executive and the planner controller, and then how far they are supported by the system. And then these little yellow rectangles basically represent these tasks. So the bigger the rectangle, the more tasks and the more prominent frequent tasks
you can see on those levels and on that cell actually, or crossing of column and row. So basically there you can see that when it comes to the preparation of decisions, so how we gather information, how we analyze information. So you think about like how the radars work, how the radar plots are represented on the radar view, how conflict detection works. Then you can see that, yeah, quite many features are there which are highly automated and they support the perception and analysis. However, when it comes to decision making, you can see that, yeah, we are nowhere near those levels. So that's why the ethicals say, hey, there's almost nothing that is really automated, because, yeah, decision making is still completely, almost completely human in ATC. And then the execution is like a bit more in between. So the next one. Basically, from there on, okay, the next question is, how do we want to proceed? So, okay, we know where we are, where do we want to get to? And then, of course, when you are thinking about that, you don't really want to reinvent the wheel again. So you look around, okay, what has happened in other industries so far? And then, of course, we did look into the flight deck, like how features were introduced there, how the pilot work was automated and actually the amount of pilots were reduced, but also in the car industry, because it's, I think, very similar. So there you can see very similar things going on right now, as old car makers are introducing more and more driver assistance systems. So there, what we realize is that basically you can follow two different approaches. You can either just go a bit more blind and just without any kind of strategy or systematic approach, you can just introduce whatever technology allows you to introduce. And that's basically path A. That's what we quite often see today with cars, and that we could also observe in the flight deck. There actually automation is completely driven by, okay, what can technology offer, what are the possibilities? The problem there, of course, is that it's not designed to support the human. It's not designed from a human-centric, human-oriented, or a system as a whole oriented point of view. It's only really technology-centered. And there you can see all the ironies of automation, all the problems, all those incidents and even accidents that can be called like automation-induced human error, when the media usually only says, oh, it's because of human error, but actually these are quite often like automation-induced human error, like the MCAS accidents as well. And then we also realize, hey, but there are some companies that are aiming for something different. So for example, Google, when it comes to the automation of the driving task, they say, hey, we don't actually need to go through all these miserable steps and then create all kinds of issues. We can also say we remain gradual, but we do this kind of gradual improvement in a different way. That means that we don't introduce some in-between step when the driver is still like monitoring and the driver is responsible and is supposed to supervise automation, but actually cannot, because you cannot expect, of course, a human to be monitoring an automated system for longer than a few minutes. Why don't we just remove the human? We say, okay, we go for full automation, but we only do it in a very specific environment. So we only do a geofenced area, and it's only where the weather is nice, when the roads are wide, where everything is a bit more ideal. And then later on, gradually, we can, let's say, expand the scope, but physically the scope, the range of automation to other areas as well. So, yeah, the next one. So basically, we try to learn from these approaches and adapt them to, or apply them to our environment, to ATC. And yeah, here is the taxonomy again. And then we try to define, okay, how can we split certain situations, certain scenarios, like the geofence areas with the cars in our environment. And then we basically realize that we can do something very similar. If you think about a whole bunch of aircraft in a volume of airspace in our airspace, you can of course also imagine that not all aircraft are at the same spot at the same time. they don't interact, they don't all of them interact with each other at the same time. So there are certain overflights which are quite often quite segregated. There are some, let's say, clusters or some hotspots, we often call them, where flights really come together and they cross each other's paths, and then you do need to do something about them, and then also it becomes a complex situation. But yeah, you can observe these different traffic characteristics within the same airspace and within the same sector even in our airspace. And there we've already observed that it's already happening in the ops room, that if you get really busy as an executive controller and you do want to focus on your hotspots, so on the real challenging complex tasks, then you can say, hey, please, my planner, who is usually rather taking care of the coordination and the preparation of the things, hey, please help me out. Could you please take care of those 2 overflights there? Okay, that's of course not going to be so lengthy in the ops room. So they of course let each other know very quickly that please take care of those 2 flights, because they are just actually too much for me. I really want to focus on my core problem. And that's what organically developed in the ops room, and that's what we wanted to learn from, and we wanted to like surf on as an existing wave. Like how about doing the same with automation, that we split basic traffic scenarios and complex traffic scenarios, and we say, okay, when it comes to basic scenarios, so no-brainer tasks and no-brainer flights even, which only pass the airspace mostly on the same level, they rarely have any kind of action. Then we just say, okay, let's do it by automation. Let's make sure that those flights are taken care of by automation in a way that they are taken care of and they don't interact with the more complex traffic of the ATCO. And then the more complex traffic, which are the green bubbles here, there we don't want to go so far with automation. So we don't want to create an out-of-the-loop situation. We want to keep the human involved as much as possible, but we do want to support the ATCOs with very high levels of decision-making support. So we do want to introduce new intuitive tools which simply show the ATCOs very quickly what the possibilities are, what the constraints are, and then the ATCO is the one who in the end picks the right solution. And what you can see in between these dashed circles is that we want to skip those in-between steps by this approach, which are the problematic ones, where the human is not really in the loop anymore, the operator is not in the loop anymore, but still responsible, still expected to monitor the situation and jump in whenever needed. So yeah, in a nutshell, as I said, we had this approach. Objective 1 is more about the preparation of traffic, and that there we would like to achieve very high levels of automation. And then the other 2 objectives are what I've just told you, is that when it comes to complex tactical scenarios, we want to create highly automated decision-making support and execution support tools. But when it comes to basic traffic scenarios, we want to automate the handling of the traffic in those scenarios. And now the floor is Peter's.
Okay. So yeah, beside my job as head of ATM development, I'm also a project manager. And actually, I'm a project manager of a project that is called Argos. The abbreviation was a real groundbreaking operational system or something. But we invented the name first, and then we said, what can it mean? The way we approach this project is with the quote that you see here on the screen, and as was explained by Adam. We want to let the air traffic controllers really focus on the real challenging work, to do what they are best at, and to leave all the routine work, the basic traffic, actually to the machine. Actually, Argos started before the automation strategy was in place as just an idea that I started working on with my brother, who is one of the software developers here. And at the dinner once, after a few bottles of wine, we said, let's make a system that I can do air traffic control at night, because at night we are burning
ATCO hours, very expensive ATCO hours for almost no traffic. So I said, I'll do it. And then, but I need a system because I don't know how to do ATC. In brief, these are the requirements that we put on Argos. The most important requirement, of course, is that the traffic must be conflict-free. And you need to respect the exit conditions that are demanded by the letters of agreement. Of course, you need to avoid military areas. At night, there are not many military areas. Argos is also done to support training, for example. But okay, I will not dwell on these requirements. This is just what we took on us in order to make it work. What is more important is that when we started designing Argos and talking to the users, we had to define the modus operandi in which Argos would be used in this basic and complex scenarios. So what you see here is that, first of all, we had the level 0 till level 9. Level 0 was that Argos does nothing, and level 9 was that Argos does everything and nobody is around. Now, when we discussed this, we said, okay, let's look into this and which levels of automation are we going to take. And we have chosen here or selected level 3 and level 8. Level 3 is that for the complex traffic, Argos will help. Argos will say, this is what I would do, but it's up to the ATCO to accept what Argos proposes or change it or modify the plan that is presented. If it's a CPDLC flight and the plan was approved by the ATCO, then Argos will execute the plan. So at the right moment, actually, it will give a little warning or an indication to the ATCO, I'm going to uplink this in 5 seconds. And then Argos will really do it. And there is no voice involved. If it's a non-CPDLC flight, actually Argos will have a pop-up as well saying, you should clear this flight as you agreed with my plan before. The other extreme is level 8. Now we have quite some discussions about level 8 versus level 9, where in level 9 I said there is nobody around. We decided to go to that extent that the ATCO is not required to actively monitor the system. So Argos will work on his own without supervision in level 8. That's our ambition, that's our goal. As was mentioned before, why? Because it's no fun to monitor a machine that is doing basic stuff, and a human is just not very good at it either, because it's no fun. It will quickly turn into not actually actively monitoring. So we said, what we'll try to build is a system that can work on its own, that is not to be monitored, but somebody should be in the neighborhood. And the system itself will indicate when it needs assistance. So you can imagine that, okay, we're thinking of giving the ATCO a different task maybe during a shift, but that he's around, or that the ATCO is really allowed to read a book or read some briefing material. And the system will then say, hey, what's happening here? I don't feel comfortable as a system. So could you, ATCO, please help me out, monitor me, and intervene as needed. Of course, the challenge we have there is that we need to build a system that is able to give these warnings at the right time, and also is built in such a way that the ATCO is put in the picture. But keep in mind, it's a basic picture, it's basic traffic, is put in the picture and sees immediately or very quickly what is happening and what needs to be monitored or what needs to be done by himself. And then actually we end up, when the ATCO says, okay, I'm taking over this flight, because imagine that there is a loss of CPDLC, which happens. Then the ATCO will say, okay, I'll have to handle this flight because I have to do it verbally. And then we're in this mixed mode level between level 3 and level 8, which is level 5, where Argos is managing certain flights, but the ATCO is managing other flights. It's a mixed level. It's going to be maybe the most complex level to develop. AI. When taking again this taxonomy table, actually there is legally no possibility now to introduce artificial intelligence in the decision and execution phases. So it's a no-go. Also, in AI, you can have machine learned models that are static while they're being used or that are dynamic. So you can have a model that is trained offline, but then the model enhances itself while running online, which is then called a dynamic model. Now, also here we say this is a no-go for safety-related systems. And the only thing that actually we are looking at now for artificial intelligence in ATC is an offline trained model that is static. So you train the model offline, you know how it behaves, and then you can use it in the online environment, so in real time, but it will not change anymore. And what we have in mind for Argos is that the vertical rate of change and the speed will be derived from a machine learned model, an offline trained model, and used then in Argos to calculate the trajectories more accurately. So yeah, that model will give the vertical rate of change and the speed as function of the aircraft type, the operator, ADES, temperature, and so on. Yeah, this is a screenshot of the Argos prototype version 2.6 that we currently have. Important on this picture as well is what we call the answer window. So for the Ryanair 288 November, the green is the plan that Argos has, and Argos also indicates what it sees around that aircraft. So Argos will indicate to you, hey, I've seen that one, that aircraft, I've seen that aircraft, and this is my whole green envelope in which I will operate. So as you see in the picture, as the flight has to climb to flight level 370, Argos, and the flight is currently at 300, Argos says, and this is something our ATCOs say, you should never clear an aircraft to a level that's not vacant. So Argos assumes immediate jump from 300 to 370. That's why it's completely green when going up. Argos also assumed that the pilot will delay his action for 2 minutes. So it takes 2 minutes in time, and then it takes a nominal minimum climb rate, so that the whole area that you see here on the left below the Ryanair 77 Lima Romeo, that whole area is considered clear by Argos, and the climb will be done within that envelope. So the answer window, very important for us, because that's the way the ATCOs will eventually accept the system, knowing that the ATCOs will be understanding that Argos is knowing what it's doing. Question we often get, why are you doing this? The main reason is to offload the ATCO work to the computer, so that there is less boring routine work. By doing that, we hope there is less stress, traffic will rise, so there is more support, but less stress, although the traffic is rising, and that the ATCO can focus on the complex tasks. Okay, the next bullet is a bit teasing. Maybe we will build a machine at the end that is more performant. We can think about green flights where, you know, the sequence of clearances will become so complex because of the, I don't know, the engine type or the type of fuel that is used, which goes beyond the capacity of a human to make the best plan of that. And there the machine maybe could do a little bit better. We're also doing it to give more time to the ATCOs to be in the sim. So yeah, as I mentioned, they're spending their night being bored. If that time could be used during the day for training special occurrences, that's actually what we think is a better thing to do. Argos can also do support in training. Today, if you want to train an ATCO, you need a few other ATCOs around him who are feeding that ATCO with the traffic in the right way, and their Argos could take over. And we want to be the first in the world doing this kind of things. How do our ATCOs perceive what we're doing? Actually, quite positive. We have involved the ATCOs from the onset. And automation is, of course, a subject that is being heavily discussed now and happening around us everywhere. As was mentioned, the car industry, automation in cars is affecting all of us. And we clearly tell the ATCOs, this is not a threat for your job. We have no ambition to build a system that is able to handle complex traffic. We even think we cannot do it today. There are too many unknowns. Well, there are pilots here. There are too many other people in the loop to make this fully automated at this stage. So we don't have that ambition anyway. In the ATCO refresher training this winter, there is a whole topic dedicated to automation and artificial intelligence. And okay, I mentioned COVID here because actually it's one of the few positive things it brought. During the COVID times, ATCOs who knew that we are building this automated system, they were actually saying, where is it now? Because I'm really bored. We were opening sectors just to make sure that people had enough hours on position, but there was no traffic or no reason to open those sectors. And also what we did during COVID was, in order to keep the ATCOs proficient, we actually had high intensity trainings to assure their competency. And this came after we announced Argos. So, and in Argos, when we announced it, we said, we want to take away the boring work. We want to give you more training, high intensity training. And then actually it came with COVID by itself. But unfortunately, Argos was not yet ready. Okay, we also use AI in the flow area. So not in ATC, but in ATFCM and airspace management. And there again, we use offline trained models that are not modifying themselves during operation. I have a few examples of what is currently being used. We have a neural network trained model that tries to predict the traffic patterns. And actually, it is obvious and simple maybe, but we see here a military area. The flights are all filed around the military area, but of course, when the military area is not active, the flights get the direct, and this is the filed flight plan, and this is what we predict will happen, and that's what we use now for better doing flow management. Another thing we do is we monitor the ADS-B reports of airports when the aircraft are still on the ground. The moment the ADS-B, the first ADS-B report is received, normally when the flight is still at the gate, we have a machine learned model for predicting the taxi times. So once we have the first blip of the ADS-B through a machine learned model, we can, and of course the airport where the gate is, what the wind is, the runway uses, we can better estimate the taxi time and as such better estimate the takeoff time and have better counts for our flow management. Another machine learned model is the minimum connection time. Actually, we based on the airport, based on the operator, based on the aircraft type, you can from data learn that there is a minimum connection time. So a Boeing 738 Ryanair in Brussels will at least be 26 minutes on the ground before departing again. We have that from looking at big data. Now, if the Ryanair is landing at 10:15 and that same airframe is planned to leave again at 10:30 or 10:26, sorry, we know that this is not possible. So the minimum turnaround time is 26 minutes, so it will not leave before 10:41. Again, there we update the timings and we have better predictions for flow management. This is our flow management position, the screen of it. What we have used here for machine learning is data mining, and actually the data mining is used to make the input menus show the most probable input that will be made. And that's the end of the presentation. What you see here is the Waymo car. If you have the chance to look it up on YouTube, it's really some nice movies. The car is driving by itself. Okay, the weather is nice, though there's not much traffic. It's basic. And the people are sitting in the back and they cannot even get in control of the car. So, Mike, that was it. Back to you.
Already a question.
Thank you very much indeed, Adam and Peter. That was really interesting discussion to see where this stuff is all headed, and good to know that it's still being thought of over a good dinner at your brother's. So I'll just ask a question just to kick off. As a pilot coming out of, for example, Heathrow and going down to the Middle East, this is at a much more basic level, but when I come into Maastricht airspace, I probably spend the first 10 minutes climbing to the planned cruising level. I'll be cleared direct to the exit point, maybe in the Wien FIR. How much work does that involve for a controller, that flight on its own? What sort of proportion of the work is being occupied with that flight?
Well, if you get a direct right away, it probably means there's nobody in the way. It's basic traffic and it's not much work. If it is busy, you will not be given a direct probably immediately, or you will be given an intermediate flight level, or so. It doesn't only depend on that flight. It depends on the situation in the sector, how much work that will be.
And to follow that up, Maastricht are very good with using CPDLC, probably far more than any other airspace that I can think of straight away. So are all those CPDLC messages sent manually by the controller to the aircraft?
Today, yes.
And
except for the squawk change. The squawk change is uplinked automatically. There the air traffic controller is not involved. But we did not get to the point yet that we can automatically uplink clearances. That's what Argos is supposed to do, but it will take still a while.
So, for example, with the frequency changes, is that an automatic function as well, or is that?
Today it's still manual. But as Adam just explained, not necessarily done by the executive controller. He might delegate this to his coordinating controller. So that's already one step. And we are prototyping now a system function. And in the first step, it's the ATCO can say, okay, at the right moment, you can change, you can uplink, you system may uplink the contact message. But it's still the ATCO has to allow it to the system in a first step. And then in the next step, of course, then we can say once that, then ATCOs will start saying, but why do I have to approve this all the time if? And then we will say, okay, when those conditions are met, we will do it automatically. And then we're getting step by step closer to Argus. And we'll start with, as you say, with contact messages. Then we will start, and only then we will start with clearances. And we are doing squawk changes already for a long time automatically.
Yeah, that's interesting. So the idea is that Argos would start taking over those functions, as you say, step by step.
Yep.
We've got one question from the floor that Adam may have been typing an answer, but I'll ask it anyway. How does Argos prioritize, for example, where 3 or 4 conflicting aircraft require vertical instructions?
Where to start? Yeah, and yeah, for example, you mentioned that we have a scoring system for Argos. So in that respect, Argos tries to create a situation which penalizes everyone, the less as little as possible. When it comes to the instructions themselves, okay, of course, Argos can uplink as many clearances as doable within the same time frame. So, in that respect, there wouldn't be a problem with sequencing aircraft. Sequencing the clearances to aircraft. But okay, whom to climb first, let's say, or whom to drop first, depends on this scoring of the solution.
And I think we have a rule now saying that the aircraft closest to the exit will be the least impacted. So if you're still far out from your exit point, you will get you will have to maneuver to get out of the way of an aircraft that is close to the exit point. Now keep in mind as well, when there are 3, 4 conflicting aircraft requiring vertical instructions altogether, it's not very basic.
Yeah, I understand, a far more complex. Well, that probably brings me on to the second question, and probably one you can't even answer, but how long before we see full automation in ATM?
No. I always say 2034, because that's when I retire. So no. And then again, what is meant by what is full? Does full mean 24/7? Complex as well. This will take a long time. And
what if you only mean like what we mentioned, that giving few of your flights to your CC and just 3 flights in your sector taken care by automation, then I guess it's a bit more than a decade, or I don't know.
Excellent. Well, that takes care of the questions from the floor. It's interesting that you said that it frees up more time to train, because I suspect this may be a theme of the next presentation as well, with automation in the flight deck. And actually, a lot of this stuff is going to require more training, because not only do people have to monitor the automation, but they also have to be able to step in and do it themselves, a skill that they probably haven't used for quite some time, to be able to sort of effectively manage that function. So, oh, there's one more question. Let me just check that. Phil's just is regarding minimum turnaround times and expected takeoff times. Is this information not already available at ACDM airports?
Yes, but all airports are not ACDM. And secondly, we see that the method we apply using ADS-B is more accurate than their ACDM information. For some airport, it's minimal, meaning they have a very good ACDM. But for other airports, yeah, they don't do it that well, the CDM part, and they don't provide the information that accurate outside. So there we can do better, and some don't have it at all. So yeah, so
Okay.
it depends on the airport. And
that just brings me to the aircraft learning behavior, because I was interested to see it can learn the behavior. I just wondered how it would do it. For example, a heavy 777-300 climbing to a lower cruise level versus a light 777A market that would only go down to the Gulf or something. There's quite a difference in behavior between those types of aeroplanes. So would it involve aircraft specific types, even flight numbers, because you know that flight number is always going to react probably to others? How would that work?
Yeah, the machine learned model would take into account as much data as we have available. So and it would learn patterns. So yeah, if the two cases you mentioned, if they are distinct patterns, then the machine will learn this, and it will say the vertical rate of descent for this one is that much with a 90% certainty, and for the other one it's another value with 90% certainty. Airframe, if available, will be used. Yeah, some identical aircraft or aircraft types, they might have completely different engines, but not completely different, but different engines, so better performances. If the data is available, a machine should, when you set it up correctly, should be able to find that information.
So this would be really useful stuff for trying to sort of implement continuous climb type operations or continuous descent operations, because you'd know the different characteristics already.
Yep.
Yeah.
And Ryanair is different than a KLM in descent. So this is known by the ATCOs, but we don't have it anywhere in any model.
Yeah. No, that's lovely. Thank you very much indeed, James. That's a really interesting presentation. I think now is probably a good time to hand over to Stuart.
Morning all. Yeah, so apologies first from me. Can I give me a thumbs up if you can hear me okay, would you guys? Yeah, fantastic. Thank you very much. Yeah, I've picked this up at relatively short notice, and I'm going to use one of my expert colleagues' presentations, at least in part, just to touch on a few of the issues relating to automation and in the flight deck. My background is that I do flight safety work for BALPA, but prior to that, I was a Airbus 320 and then latterly A380 captain with a big airline until not too long ago. So I'm not flying now. I've got a reasonable understanding of these systems, but what we really want to extract from them is just the overview rather than digging deep into the technical detail and the SOPs related, because it's come out, as you know, we have regular meetings with our GATCO colleagues at BALPA, and Phil sits on our Air Traffic Services Committee, which Mike chairs, and we often talk about these things, and one of the benefits of getting together is that we don't really hook up as much as we probably ought to and share the knowledge, and that's the objective. And it comes out that, you know, we often don't, as pilots, understand what's going on in the air traffic arena, and air traffickers perhaps not so much what's going in the flight deck. So I'm going to touch on a few of these automation systems, and then hopefully that will spur a little bit of a discussion and some Q&As, and we'll go away with a bit more understanding of each other's position. So I'm going to do a screen share and show you a few slides, and I'll talk over the top of them, and then I'll come back and we can see if anyone's got any questions and if there's any discussion to be had on the subject. So just once again, though, this is not my expert area. I'm not trying to do a technical presentation. It's an overview situation for those who are less well versed in sort of Airbus and pilot related automation. So let me try this screen share. Fingers crossed, everybody. where are we? There we go. How's that? Thumbs up if you can all see that slide. This is BALPA's flight safety committees. We've got a really big structure of non-industrial technical flight safety work, and that's a list of, it might not be all of the technical committees, but that's the kind of broad panoply of what we cover in BALPA, and we have GATCO reps who sit on and assist in a number of those areas. Most obviously the Air Traffic Service Study Group, Phil is currently our rep from GATCO who we meet with, as I mentioned. So to go on to the systems issue, now this is very Airbus heavy, and that's because I've flown Airbus all my flying career. Mike, on the other hand, was a long-term Boeing trainer with extensive knowledge in that area, so we can bounce backwards and forwards between the two aircraft types if you like. But the only reason why this is Airbus is that my expert colleague who prepared this presentation is an Airbus man as well, but it just serves to illustrate some of what's going on in the flight deck. Hopefully you have interest to the ATCOs online. The first thing we're going to talk about is auto TCAS and a quick overview. So when an aircraft gets, we all know what TCAS is, and we know that there are procedures that the pilots carry out in order to avoid airprox situations. But on the modern Airbus aircraft, the 380, when I flew it a few years ago, that had this auto TCAS, and it will fly an automatic avoidance routine and then return itself to its previous assigned clearance. So just a quick overview of how this looks like and how it pans out for the pilot who's aware of what's going on but monitoring. The idea here is, I hope you can give me a thumbs up if you can see can you see my cursor on screen? Right, yeah, brilliant, great stuff. So what we've got here is, this is an A350 trundling along, and there's a big old A380 coming in the opposite direction. And at the moment, these are the mode selections. So this is what the pilot will see at the top of his primary or her primary flight display. And as soon as there's a traffic alert, the aircraft goes into arms this TCAS mode in blue, and the pilots will talk to each other and say that they've spotted this is coming. And when the resolution advisory occurs, the aircraft engages in its TCAS mode, so it's now active, and you can see essentially, quick overview, it pitches itself up, puts this is the vertical speed indication, pops that up into this green band, which is like the target to avoid. It will climb up over the traffic, the conflicting traffic, and then as the clear of conflict is announced, it will engage. So the target aircraft has passed, it will engage a minus 1,000 feet per minute rate of descent, and it will descend back to its original assigned altitude, alt in blue, and then it will capture that green altitude and it will trundle along. And in theory, all of this occurs without any pilot intervention whatsoever, although they will be there monitoring. So I guess the idea is that if there's incapacitation, that the aircraft should make itself safe, even if the pilots are unable to interact for some reason. Moving on to, I'm trying to make this screen share work properly. There we go. All right, next one. It's a bit slow to react, so I do apologise. So this wasn't something that I was aware of, but automatic emergency descent. So I guess the scenario is that both pilots are incapacitated due to explosive decompression, and the aircraft will itself sense those conditions. It will look at what the cabin altitude is, predict that it's going to exceed its 14,000 feet threshold, and then it will actually engage in emergency descent of its own volition. You can see on the primary flight display, here is as a warning comes up, there'll be other associated warnings going off, especially if there's a decompression. There'll be lots of other notifications coming to the pilots and warnings and cautions. And you can see a little bit like the last auto TCAS, you can see that although it's at a max, its Mach number here, it's cruising at flight level 350, and its nav means that it's following this green line, the flight path, the pre-programmed flight path. In actual fact, it says it's going to do an auto emergency descent in 9 seconds from now at this point in time. And there's the armed emergency descent mode showing in blue. So next stage, what it's actually done is executing the emergency descent. It's thrust idle, so it's put the engine thrust to 0 automatically through the auto thrust. It's engaged emergency descent mode. It's gone into a heading mode, so it's come off the pre-programmed flight path. That's now gone into this dotted line. This is the line it's going to follow this heading. And it's descending to flight level 100, or in certain circumstances, if there's a higher minimum en route altitude that's in the system. And it will make that descent to this low safe level. And then finally, it's now got down to that, whatever the level is that's been set. It's captured the altitude. In this case, it's flight level 163, and that's relating to the en route altitude plus a bit of margin. And it's actually slowing down, as we can see, to 225 knots, which is, it's probably what we would call in the Airbus a green dot speed. It's like the best lift to drag. And it will cruise along now in heading mode at that height, slowing down to this low speed. And so you've got a safe position, even if both pilots have been incapacitated. Finally, another one which is of interest to the air traffic controllers when we've chatted about it, and this was on the A380 as well, and I understand it's on the A350 and other aircraft are benefiting from it, and it says brake to vacate. So instead of pilots after landing applying their brakes themselves manually or pre-selecting an auto brake mode commensurate with the level of deceleration that they wish, whether it's a short runway, a long runway, or whatever the runway surface conditions are. In these aeroplanes, you're able to specify which turn-off you wish to come off at, and that can be done in collaboration with air traffic control. And one of the benefits of this is, well, they're on the screen there, but massively reduced brake wear, because the aircraft will only just apply enough brake in order to come to a low speed adjacent to the turn-off position that has been selected by the pilots in theory. And so there's costs benefits, there's passenger comfort benefits. Here's a little overview. This is now the map. So this is the nav display. And what you can do is zoom right in on the airfield, and you can see a demonstration or a picture of what the airfield looks like. And you can see through interaction with the flight management computer side of the aircraft, you can actually select which exit you've been told by air traffic control, perhaps, that you're going to be able to use. On touchdown, the aircraft will apply the brakes to test the surface condition, and then it will subsequently apply the braking in order to bring the aircraft to a low speed at the right point. So on the one hand, that all sounds great. And none of this is AI, of course. This is just really sort of automation, although it's pretty enhanced automation. But nonetheless, we know that there are issues around automation, aren't there? Training, knowledge of failures, safety procedure, and all that kind of thing. So these are the issues that we have to think about, the training issues of these enhanced systems. And hopefully that little overview there of some of the things that are available to pilots now will be of interest to the air traffic controllers as well. Questions that typically come up about it is, can you change the selected intersection if you want to come off earlier or later? And a little bit like many issues, early knowledge is good, and you don't really want to be programming the FMS at a very late stage during the final approach. What if the runway surface conditions aren't as good as they ought to be? Or if you land a bit deeply, well, can the pilots intervene? Well, yes, because they just go through onto a manual brake application and fly the aircraft or brake the aircraft in the way they always have done in time-honored manual fashion. So that's a little bit of an overview. I'm going to go back to that slide in a moment. I'll stop sharing the screen at this point. So that's my little overview, which is a very non-technical skim through what my colleague was going to give you a more technical explanation of. And I wonder now, Mike, we've got a couple of questions up there, and we can proceed with some Q&A as well, and discussion around the issues of automation, perhaps.
Yeah, absolutely. Yeah, thank you, Stu, for going through that. That's brilliant. And I know it was tricky, as you're an A380 man and hadn't progressed as far as the 350, or it hadn't even come out, I don't think, when you were flying the A380. Olivia just asked a question that you may or may not be able to answer. For the auto emergency descent, will that take into account minimum sector safety altitudes, or will the explosive decompression take precedence, as that could lead to additional problems in mountainous terrain areas or areas with restricted or danger areas activated?
So with the caveats as before, that this isn't my specialist subject, but my understanding is that the aircraft's got these minimum en route altitudes, and so what it will do is select some sensible minimum plus a margin, or 10,000 feet, whichever is the lower. So it's not going to go hammering down into Mont Blanc. I think one of the areas where it does need that level of supervision, my understanding is that if the minimum en route altitude in your little bit of terrain under the aeroplane right now is quite low, but you've got high ground coming up, I don't believe that it's now going to do anything about that. It's going to fly along straight and level until, well, probably the next thing you're going to find out is a GPWS warnings going off. Now, I might be wrong about that, but that's my understanding. But essentially what this is a belt and braces safety net to get you going down, and to do it in a sensible way without busting any limiting speeds, and in order just to initiate, and then hopefully the idea is that the pilots on oxygen manage to take full control of the situation, and they will manage the flight path. So once the emergency descent has been completed by the system, it's basically holding that altitude, holding that heading, flying along at a relatively low speed. It's in a sort of semi-safe condition, but the pilots would therefore have to interact with it in order to navigate back where they were going, make an alternative plan, a diversion airport, climb above higher ground, or whatever.
Brilliant, thank you, Stu. And there is another question there about, you may be able to answer this with a 380 experience, because I'm not familiar with, obviously, the Airbus checklist, but is there an accompanying checklist to an emergency descent for a call to ATC and a change of squawk to 7700?
Yeah, all of the normal emergency procedures are still in place. So if you assume that the pilots are still both compos mentis and carrying out their SOPs in the normal way, there probably wouldn't be, to the ATCO's eye or ear, any difference. And in many ways, that's an interesting, that's why it makes these discussions like BTV, the brake to vacate system, BTV, an interesting discussion, because superficially to the ATCO, there's no difference. And yet actually from the pilot's perspective, there could be a lot of difference, quite an increased workload, perhaps, to make changes into the FMS, or in this instance, perhaps a reduced workload when initiating the emergency descent, but then perhaps because they've been slightly out of the loop, they've now got to recover the aircraft's control and then reprogram and take it back where they need to go, you know. So maybe that, I mean, that's probably highlights one of the critical issues here, is that except in the unusual situation of, say, both pilots being incapacitated as a result of an emergency descent, obviously the air traffic controller won't hear anything because they're incapacitated. But the aircraft now, instead of trundling along at high altitude and, you know, to everyone's inevitable doom, is going to initiate this emergency descent, and there's a very good chance of the situation being recovered. So that's probably the best I can say about that. Does that answer the question?
I think it does. I think it answered it very well. I was just trying to think to link these two presentations together, because it's interesting that if I understood Peter and Adam correctly, that you can select the level of automation that you get from Argos, whereas in the aeroplane here, the examples you're talking about, auto emergency descent, auto TCAS, it's all or nothing. the automatic system is doing it. And there was a question that I didn't ask Adam and Peter before, which said, who will determine the conditions in which Argos is used? Will it be the written in procedures, or will it be individual controllers' choice?
It's a supervisory decision. Like today, the supervisor decides to open a sector or close a sector. It's also a supervisor decision to enable level 3 or 8 based on, of course, Argos's advice. So Argos will say, Argos will say, I think I can handle level 8 with this traffic. Argos will say, I'm not able to handle level 8 with this traffic, but only level 3. So Argos will say these things to the supervisor, but then the supervisor might know additional things. If a sector is in training, or one of the neighbors has a system night and their system is in maintenance, those are conditions that the supervisor will say, okay, although this is basic and the system could handle it, I want the people there because of external factors. But it's we compare it to the decision of a supervisor to split the sector or combine a sector. It's the decision of the supervisor based on Argos inputs and everything he knows to authorize a level 3 or 8. And then it's the ATCO who will say, okay, my assessment as well is that it's okay, and they will engage.
And interested, if I understood you correctly, that it can work the other way around, where the Argos can turn around and say, actually, I need help.
Mm-hmm.
And from the human, as it were, to step in and help. It sort of reminded me of 2001 film where Hal turns around and says,
Yep.
I need help.
Yep.
The thing is that, what you also mentioned, and I think it's an important point, is that, of course, in the cockpit and also in a car, it's even though not the entire driving or flying task is an all or nothing concept, but the different tasks are. So you cannot usually go for a hybrid modus when you look at a certain task. You either do this or that with it because they're just one aircraft that you fly. In ATC, what we have indeed the benefit that we also have an extra dimension, like, okay, we only give certain flights to automation, which means that the ATCOs are still able to exercise or practice their skills at all those other flights, which are probably also the more challenging ones. So basically, you don't remove tasks altogether, only those ones, of course, and that's something we have done already, which can be automated at all levels, also in the fallback system, and they are not part of the core workflow, like separating traffic.
And practicing their skills is a really important aspect of this. So you can do it incrementally and sort of take and adjust your workload. So it's even the pilot in the A350 there. Hopefully, and I'm sure normally, the auto TCAS system will function absolutely normally, but in the event it either doesn't or maybe gets confused by the scenario it's presented with, then suddenly, Stuart, I think the pilot is going to have to step in and do an exercise, a procedure that he may or may not, or she may or may not have practiced in that in the previous few months or maybe longer.
I think you've hit on an important point there. You know that I mean we aren't talking about AI in the flight deck right now, at least. Although there's much talk about autonomy and all that sort of thing, but we generally there's a lot of parallels which Adam and Peter have discussed. We're trying to automate tasks. And that's very good. That's tasks that the automatics are supervised by the pilots. But one of the problems you've got as you increase the complexity of systems and you automate these routine tasks that pilots can become, well, it's used as an insult, but I don't believe it is, but this idea of de-skilling, where people are not routinely carrying out the manual tasks. So it's actually starting to ask too much of someone to suddenly, once in a very long while, drop them into a situation where they need to manually intervene against an automated system that's not coping well. And so we've talked a lot, haven't we, about, you know, training and I know with your extensive training background, you know, that kind of perversely in many regards, counterintuitively, the more automation you've got, the more practice you need to schedule for people to practice the manual handling techniques and all of those sorts of issues, because otherwise, if we're on the line and we're operating these systems in SOP in the way they're intended to be operated, the pilots are probably not manually intervening very much, if at all. And then once in a while, you get a big event that occurs, which requires an extreme level of manual input. So even going beyond perhaps the auto TCAS that doesn't quite work out and the pilots have to intervene, you know, if you sort of look to something like the you know, very famous Miracle on the Hudson, the Sullenberger incident, he had to take control of that aircraft, extreme amount of decision making and expert manual flying in order to execute that to an outcome where there were no fatalities whatsoever. And that's probably that's testament to his massive experience and skill, and he'd been a military pilot before and in a lifetime of manually handling aircraft. But you know, if you imagine project ahead 20, 30 years from now, when perhaps the automation systems are almost perfect, those sort of black swan events that come around once in a very long while, there won't be those basic skills for people to fall back on, because they just haven't been practicing them or using them in a habitual manner. In other words, it sounds to me like, you know, the training regime needs to be completely rethought. The more automation that's introduced, then the more practice needs to be timetabled for exercising the manual skills.
Yeah, that's an extremely good point, and it's the point being made in both, excuse me, both presentations. So an interesting comment from Terry, who's popped up on there and said, are ATCOs, I'll have to refer to you guys, Adam, Peter, but are ATCOs aware that automatic emergency descent mode varies with different types? For example, the Gulfstream business jets will always turn left 90 degrees and descend to 15,000 feet.
I don't think so.
So clearly every manufacturer is going to come up with maybe slightly different solutions to the issue.
There's so many analogies, aren't there, with even the self-driving cars, and how are these things going to interact with each other? Right? If each manufacturer has got its own technical department developing solutions, and they don't interact particularly well. I mean, the TCAS probably is a good example, because it's rigorously imposed what the system should do in response to a TA and RA, and the two aircraft, the conflicting aircraft, coordinate effectively with each other in order to gain a safe outcome. But it strikes me that I mean, I didn't know this about the Gulfstream, Terry. It's the first time I've come across that. It sounds to me like industry needs to come together in order to, and regulators, to develop a unified response and define what the outcome should be. You know, that we've got these automated systems, but they are perhaps producing outcomes which are suboptimal, or that don't coordinate with the equipment of other manufacturers. And even for pilot training purposes, you know, we would talk about overload when you get system failures, or just doing the conversion courses. You go from one aircraft type to a different one, and the terminology is different, and the three-letter acronyms are all different, and the processes and procedures are different. And it's very, very difficult to you know, to dump all that from your brain when you move from an Airbus and you go to do a Boeing course or vice versa, or whatever. There really needs to be some harmonization across the industry of these responses to the systems will carry out. It sounds to me.
I was just thinking of the survey, Stuart. You might remember it better than me. That came out from ECA, the European Cockpit Association, about the number of TCAS incidents that weren't correctly flown, and it was an amazingly high figure of TCAS profiles that weren't correctly flown. Like they were flown contrary to what the pilots were receiving in the flight deck. So I guess that auto TCAS obviously will always come up, as you said, with the correct response. And there is a question actually from Alan, who just asked, if you're overflying a busy terminal area and a descent is required, will TCAS still protect in the descent?
Well, my understanding, I mean, you might know this better than I, Mike, but my understanding that the system is robust, and in simple conflict scenarios, we'll deal with them, whether aircraft are in the climb, in the descent, or whatever. You know, one's at a level and the other's climbing to that level, and it doesn't look ahead either, does it? So you get these sort of responses where an aircraft's actually going to level off 1,000 feet below, and if the climb rate's a little high, then you can get TCAS, a false sort of TCAS RA, as the two aircraft come into conflict. So that my understanding is that it does respond correctly when it's working well, and I think that's the thing, is having done use the auto TCAS in the 380. The odd thing about it is that the pilots will have seen the conflict in traffic, or will be aware of the conflict traffic, and then you see that blue armed mode come up, so that you know that you've got traffic, and you know you're waiting for it to actually intervene. And it seems like it takes an age. The pilots would probably have intervened already, or certainly would have done something and talked to each other, raised awareness with air traffic control, but you're sat there and the heart rate goes off the clock as you wait to see, is it actually going to intervene? And then it intervenes. And there are lots of issues like that where perhaps it's doing it at the last possible moment, but if it is doing it at the last possible moment, or at some quite close approach moment, if it doesn't intervene, now the pilots are going to have to intervene themselves in quite a rush. So, you know, that's one of the issues with automation, isn't it? That you sit there just watching it like a bit of a dummy, waiting to see if it actually is going to interact.
Absolutely, absolutely. Another question for Adam and Peter. Do you see Argos as being transferable to different ATC environments, for example, tower, approach, procedural?
Of course.
Care to expand, or?
Yes, as long as we can figure out what basic traffic is and what needs to be done, then it can be done by a system. Yeah.
Okay, lovely.
Yeah, I don't know enough about type of operations in tower and all that, but basically this is true for everything. If you can say, well, in this situation it's easy to do, and that's the way you do it all the time, you know, you can automate it.
And interesting, the artificial intelligence side of it, excuse me, seems to be limited to learning behaviors, you know, learning aircraft behavior or learning taxi times and stuff, with no plans to sort of make it do more. It's just
Okay,
there to help you, maybe.
You should be aware that EASA is currently developing the rules and guidelines for using AI in air traffic management. And their first focus is on this offline machine learned models for the data analysis phase maximum. So even in the rulemaking bodies are not yet there to allow or to explain what the rules are to allow AI in decision making and in execution. We're just not there yet. Not even with the rulemaking. So for sure not with the implementation.
Yeah, so we still seem to be talking about our step-by-step.
And also implementing automation without AI is very difficult. Implementing automation with AI is going to be even more difficult. So let's do it step by step and first tackle automation in a deterministic way. You know.
Okay.
Can I jump in on something there, Mike?
Yeah, please.
We're talking about automation and then AI being the next step, you know, and obviously we've got the self-driving cars, and now the technologists are looking to self-flying aircraft and all this sort of thing. And sometimes some of these ideas are based on, it's not that they're not technically feasible, and especially in completely segregated airspace where the only thing that an autonomous aircraft is going to bang into is another autonomous aircraft, as long as there aren't tens of thousands of people underneath, you know, it's over a city. So you can see there are problems, but sometimes it feels to me, and now I don't fly anymore, so I've got no skin in the game, but it feels to me a flawed premise is used often to justify these sorts of things. And I've got a slide which I'm going to share with you briefly, if I can find it. Hang on. Some people will have seen this before. You guys might have seen it as well. Can you see this? Thumb up. Yeah, it's shared, right? This is some data from John Holbrook of NASA, which came. Well, he's often talked about this, and he talked about this at a BALPA flight safety seminar some while ago. And what you've got is this sort of false justification for removing the pilot from the flight deck to say that something like 70 to 80% of all accidents have got a human factors aspect. And therefore you've got this kind of simple-minded and clearly fallacious idea that if you take the pilots out of the flight deck, then you'll get rid of 70 to 80% of all the air accidents, which is patent nonsense, but it's genuinely used by people to justify self-flying aircraft and self-driving cars and that kind of thing. The same arguments, actually, I've listened, there's a thing on the radio and they were talking to one of the Teamsters union officials in the States, you know, they're the guys who have the truck drivers. And the same sort of arguments been talked about there, where accidents are caused by human error, so get rid of the human and there won't be any accidents. But the problem is what they're not looking at is the whole pilot saves thing, which has been something that we've been thinking about at BALPA for a long time. And so on the face of it, if I use, I've got my cursor, there we go. So this is in this 10-year period, 2007 to 2016, they found there were 310 accidents attributed to human error. But in that same period, there are 244 million departures and a total of 388 accidents. But what came out with, so what John Holbrook's investigations brought to light was an estimation of pilot interventions of one kind or another on 20% of all normal flights. And that intervention, it could have been anything, you know, a tripped circuit breaker, a reset of a computer, or maybe taking control because the aircraft's flown through the localizer, or, you know, anything from unimportant to potentially serious. So 20% of all normal flights in that 10-year period is nearly 49 million flights where there was a human intervention which may have resulted in some form or other of incident or accident. And that's what you're not getting, you know, when you take the human out of the, and it strikes me that you have rationalized the same thing with air traffic control. If you take the human completely out of it, you might get rid of this 310 here, but you might introduce 48 million potential incidents and accidents because of the lack of a human. And I think that's something that outside of the problem that BALPA has and other organizations like us is that when making safety arguments like this, they're often categorized as, well, you would say that, wouldn't you? You know, because you're pilots and you don't want to see self-flying air taxis and what have you. We're not fundamentally opposed to technology, but nobody truly addresses that issue of the benefit the human brings. And the extreme example is like the Sullenberger case, because I say, you know, had that been in 20 years' time, and that was an autonomous A320 taking off out of LaGuardia, double engine failure at 3,500 feet, would the automatics would the machine learning over that time, would the AI have had sufficient capacity to bring it to the successful conclusion that he did with putting it down on the river, you know, and doing it in a safe way? And well, I obviously don't know the answer, but I've got a pretty good idea. I don't think it would have been as good an outcome.
Excellent, Stu. Any thoughts on that, Peter?
Yeah, that's we don't have the ambition to replace the GATCO. We don't have this ambition. I don't even have that capability for the moment because of those 50 million cases you show when it's complex that a pilot does not react immediately and then there is a wind that is unexpected. Then you need a human, and the human will take care of it. And we fully acknowledge this. So I think what is interesting in the aircraft is to automate this actions that, in case the pilot is not able to so like the emergency descent, I think is beautiful because it's the case where the pilot may have passed out, and if then the system would not do anything, I mean, yeah, the consequences are known. So for these functions, I think it's really cool.
Yeah, I think that, I mean, that goes to that whole idea of appropriate use of technology, doesn't it?
Yeah.
And that's what it is. So auto TCAS as well, if they're very low alertness, or one of them's popped out the flight deck, or the conflict in traffic has not been noticed, if the aircraft takes action and the collision is avoided, how is that a bad thing? But if you then layer up all of these automatics and you build a fully automated, autonomous sort of system like that, nobody's going to intercede on those few occasions where the auto TCAS gets confused, or where it's correctly executed the emergency descent down to 2,500 feet, with high ground ahead, and those sorts of issues. And we can't imagine those scenarios, what they are. But if you've got a person, then you've got the issue. If you've got someone there, then it's an issue of training. And we have to, as I was very impressed with what you'd said there, that you use the opportunity of COVID and the very low workload to get the ATCOs out and into the simulator to give them that opportunity to practice.
Yeah.
And it was something I always used to think, really, we have our regular sim checks, and Mike would have conducted hundreds, thousands of those over the years. But often the sim checks, it's a kind of a regulatory minimum level of input required in order to get your license signed, etc. It would have been great to have more rostered non-jeopardy practice, I think, because there's always whenever you go in for a check into a formal sim, there's always a measure of jeopardy, isn't there, Mike? And you need to perform well. And as a result, you get this really, again, something we were laughing about yesterday when we were kind of throwing this together. This idea that in times past, you used to say, well, you would practice on the line for going in the sim. So a month or so before you got your big sim check coming up, you would do some hand flying. Or, if you knew it was an AWOPS, low visibility procedures type of sim coming up, you'd do a couple of auto lands, because I never did auto lands unless I had to. Who does? Who wants to fly? You want to fly to a manual landing, and all those sorts of things. And it's bizarre and counterintuitive that you should practice during the day job to take it into the sim. Surely the sim's where you do the practice.
Absolutely. we're just coming up to the end of our time. If I can maybe ask, this is the last question, excuse me. If the auto TCAS doesn't work as intended for whatever reason, and there's an incident as a result, whose responsibility is it? And would the same be true if there was a similar issue with Argos? Your closing question.
Shall I take the auto TCAS one? So my view is, at the moment, right now, the pilots are completely responsible. And okay, I think we understand that. But as systems get more complex and layered, and they become more out of the loop or less well practiced, then surely that connection is getting muddied. And it goes, there's a grey scale all the way to this sort of theoretical autonomous aircraft, where I've been to a few events, drone related events and, UAS events. In extremis, there's no pilot in the flight deck. Then somebody's got to be responsible. And surely that's therefore the operator, i.e., the airline, or the systems manufacturer, or even the software engineer. So, 20 years later, let's say in extremis, 737 MAX had been a fully autonomous airliner, the first generation, and then those two awful accidents occurred. I think we're going to see software engineers in the dock for manslaughter, aren't we? And this is something that people have got to get their heads around. Oh, that's just my view, but there's always a fault to be found where some major fatal accident like that occurs.
Yeah, if I may give my view on that as well. So first of all, regarding Argos and who's responsible, we deliberately choose not to put an ATCO in front of the screen in level 8, because we said it's not the ATCO. And okay, it's our ambition. Whether we will get there or not, that's our ambition. So in the case of level 8 operations from Argos, it is the system side that is liable, that is responsible. Now, the next element in there, who from the system side, and I call it system side in general. For that, I don't think it will be the software engineer, Stuart, that will be held liable unless he broke the rules. Now, to build these systems and to build aircraft as well, but to build ATC systems, there are rules, there are regulations. You have to do this and you have to do that, and you have your procedures. Those procedures are in place for protecting the people that are building these systems. So as a software engineer or a test engineer or a designer, as long as you respect the rules, it will not be, in my opinion, you personally, but it will be the organization or even the one that set the rules. We have done a legal case on Argos already, or actually a liability case, and what struck me there, and it's really, yeah, but it's the truth. You can have as many rules and procedures and things in place. At the end, it's the judge who decides. And if you have a, okay, I'll put it in extreme. If you have a judge that likes you and he thinks you did enough, duty of care, he will say it's not you. If you have a judge, exact the same situation, who does not like you, or and he says, well, you are liable, then you're liable. It all depends on the judge. But okay, get philosophical maybe.
Gentlemen, that's I think that's a really good place to end a really interesting discussion. 90 minutes is never long enough to sort the world out and sort this particular issue out, but hopefully it's informing each group, pilots and controllers, better of their roles and what's coming up in the future and everything. So Adam, Peter, Stuart, thank you very much indeed for your time. It's been really good. Just to say to everyone that the session will be available online soon. So those of you who've been working, then it's all available to watch there soon. When you leave the meeting, a feedback form will appear. It would really help us if you could just leave your honest feedback about what you thought of the presentation, what maybe we could do better, or what to put in or what to leave out. Anything will help us. The next session is next Monday, again at 10 o'clock, 15th of November, same time, and it will look at the our impact on the climate and its impact on us. And we hope you'll be there to take an active part in that particular event. So wish you all a very good morning. Thank you again. Bye.
Thank you, Mike. Bye-bye.
Thanks, guys. Nice to meet you.
Nice meeting you.